setting sun? Is a smoking gun? Is a four-letter word? I hope it hurts. Love is a fatal flaw. Is a broken jaw? Is a burning bridge? Move your hips. King-size bed was an escape plan, was an open hand. Now it's a dog from hell, it's a dream you sell, it's an epitaph, it's a photograph.
Good evening, good afternoon, and maybe even good morning. Welcome to the October 2020 installment of OWASP Ottawa, where I'm speaking to you mostly live from my COVID bunker. I'd like to welcome two great speakers this evening a little later, but before I do that, I want to talk about a couple of public service announcements about OWASP Ottawa. The first one is how to get in touch with us, and the slide you should be seeing now has all the great ways you can connect to us, either on our own Slack, or through our Twitter handle or our LinkedIn page. And of course, you're here on YouTube, so you already know about that. The next thing I want to point out to you is the survey that we are starting, which you should see the link for, and its password. Yes, I know it's on a live stream and on YouTube, but there's a password for it anyways. For a new survey that we have, and it's essentially, we want to ask the question, if anybody is interested about workplace stress and workplace mental health, particularly in IT and security fields. So the survey is completely anonymous, and it essentially asks the question: if you had the opportunity to ask a clinical psychologist about workplace stress, what would you ask them? And based on our responses in 2021, we will try to arrange a presentation based on the questions you would want to ask them. And that is essentially all I wanted to talk about in terms of our slides. But first off, I'm going to add Tom, who's going to give us a quick pitch about something related to CTF.
That's right. Can you hear me, Garth?
Yep.
So I'm going to assume everyone can hear me, and I'm going to share my screen. Screen sharing. Yes, share screen. All right, let me know when you can see that. Ooh, Inception. Garth, can you see my screen? Oh, I can't hear you,
Yes,
Garth. Ah, good. Okay, so here we go. Thank you very much for having me. I'm just going to take a couple of minutes here. It's a very crowded slide, but it talks about CyberSci, which started running 5 years ago. It's a cybersecurity challenge for students. The essence is we have a one-day event on a Saturday where the students from all the local universities and colleges get together. We do hacking in the morning, interviews in the afternoon, and job offers by supper. So it works out really well. The employers love a chance to actually work with the students on some live action event. And the students like it because they get to meet the employers and maybe line up a job right away, especially if you're one of those students who you can't get a job because you never built your resume, and you can't build your resume because you can't get a job. These events work out great. So been doing it for a number of years. There's probably about 30 students now have gotten jobs through this, and we're doing it right across country: Ottawa, Montreal, Toronto, Vancouver. Last year we had trouble with COVID. We only got through 5 of those cities, and we were on our way to Halifax when things got shut down, but we're carrying on. So we're carrying on by video this year, and hopefully we'll have a live event. The winners from each region come to Ottawa for the big finale, and the 2 top teams from Ottawa represent Canada at the international cyber competitions this year in Prague, Czechoslovakia. So that's all the good news. And the bad news is our webpage sucks. So I'm going to jump over to that as if it needs to be demonstrated. So here's a web page. Okay, yours truly, WordPress, 2011, got a theme called Blogo Life. Put this together. Honestly, considering it's 9 years old, I'm not too embarrassed about it, but obviously it needs work. It's the old style here. It's just a brochure style. We're just giving out information. There's nothing interactive about it. But there's drop down for each city. So here, I'll show you the Ottawa one. It talks about our event. We have, a couple of pictures of what was going on. Jim Watson, the Mayor of Ottawa, is our honorary patron, and he comes each year to hand out the trophy. Didn't get a picture here, but I should have one of him. Anyway, but there's our problem. So the website is pretty basic, and I won't take up much more time. So I'll just say we could use some help. I've had a number of people kind of volunteer to help out, and that's a tough commitment, and each one of them has lost interest before we got very far. So I'm literally looking for someone. This is a nonprofit organization. We want to do a better job, but we want to do it for not too much money. So I came to the group here. If there's anyone that is interested in maybe having fun, doing a website, group of volunteers all working on this program. We could even find some money to pay some costs, but we're cheap, I'll be honest. So I'm hoping there's somebody out there that has an interest in helping out and doing a good job. There's lots of examples on the web of this kind of website. All I really wanted to do, I know I'm scrolling quickly here, but was just take our information and put it in a nice new format. And I can't even find a WordPress theme that lets me to do that. They all look great on the demo, and then when you try to put your information in, it looks crappy. So I recognize I need help. So there we go. Last point then is top right is my contact info, tom.lavasser@hackingway.org. If anybody is willing to help out, just shoot me a line right there. And I'd love to hear from you. So that's it. A few hours, get the thing done in a few days, in a few days of work, hopefully. And it'll be pretty static the rest of the year. So it's about that kind of a job, that size, that shape.
So it seems like a little bit more than a web or a WordPress foo kind of thing.
Well, I got to say the demos of this type are WordPress themes. This one's a beauty. It's got it's made for conferences, so you can have a nice heading. There's, widgets for a countdown. There's widgets for where you put in your guests. There's widgets to create your agenda. So this one should have been great. I actually paid $195 and got a copy of this very theme and plugged in our information, and it looked like crap. So I need somebody who's either really super comfortable in WordPress, or if somebody's actually a developer and has their own, theme or basics that they use. We'll take anything. We'll take anything.
All right. Well, good luck with that.
Thank you. Thank you. And thanks for the time. Appreciate that, Garth.
No worries. No worries. Okay, so let's move over to our first presenter of presenters, I should say, of the evening. I'll let you see if you can share your screen while I'm doing an intro. So I'd like to introduce Brent Carrara and Wei-Yun Liu. Now, first of all, Brent is one of our serial presenters. He's presented to us before, and we've always enjoyed his content. I'm not sure what the gateway drug for him for becoming a security professional, but he was originally a developer, so we all have a story that way. And he's currently the head of security at Ario. He's got a bachelor's degree from the University of Waterloo, but we won't hold that against him. But not being complete with that or satisfied with that, he went and got his master's degree from the University of Ottawa, and a PhD also from the University of Ottawa in Covert Channels. And I think that's probably a little bit more than cable TV. Anyway, so he's published, and he works, he's published in biometric authentication and covert communications. Also, Wei-Yun Liu is a developer at Thinking Capital. And he also has spent time kicking around the hallowed halls of universities, including the University of Ottawa. He's a mathematician who's fell into the cryptography trap. And as with all good cryptographers, you have to be, and this is a mandatory requirement, you have to be a bassist in metal bands. So without any more slaying of their bios, I'm going to pass it over to them.
Thanks, Garth. Can you hear me okay? And you can see my screen okay?
Yeah, well, no, I can't see your screen. I can see you and Wei Yun, but I cannot see a screen. Oh, wait a minute. I got a... One moment, please. I think you... There, nope, that wasn't it. Wrong one. That's another one. There it is.
You see it now, okay? And you see the presentation now?
One moment. Let me get there. There it is. There we go.
You see the presentation okay then?
Yeah. Now I can see it.
Perfect. And okay, excellent. You can still see it. I just full screened it, so I just want to make sure.
Yep.
Excellent. Okay, well, I'll get started. Thanks very much for the intro. As Garth mentioned, Wei and I are here to present. Actually, we're really excited to present on a couple of libraries that we've just recently open sourced to solve a particular problem that we initially had with Ario, which is what my bio indicated. Recently, both Wei and I have joined Thinking Capital through a merger of Ario and Thinking Capital. So they've been open sourced libraries now under the Thinking Capital brand. And the libraries come together to essentially solve a particular problem that we had, mainly to mitigate the risk of data breach for us as a company. So I'll get into the details of that. I'll motivate it through essentially a threat model that we performed while we were Ario. When we started the company a few years ago, we knew we wanted to build a financial services platform for small businesses. So we were able to kind of go through a fairly detailed threat model at that time. And one of the particular risks that we wanted to mitigate was the risk of a data breach. So I'll talk about the threat model that we looked at in particular to that risk. Some of the additional security requirements that we considered as well as a development shop. We wanted to make it quite easy to use for all developers while remaining secure, of course. So I'll get into the details there. I'll examine quickly, but I'll examine some of the existing solutions that we did consider and talk about some of their drawbacks and why they weren't particularly relevant to how we wanted to go about solving the problem. And I'll introduce essentially version 1 of the architecture that we developed to solve the problem. And then I'll pass it off to Wei, who will get into some of the performance issues that we ran into and essentially how we've solved them in version 2. And of course, we'll end with some trade-offs and next steps and conclude. So to understand essentially the problem space that we were in, I'll give a brief intro to our company. So as I mentioned, we are now Thinking Capital, which is a financial technology company based out of Montreal, Toronto, and Ottawa. We are focused on providing financial services to small businesses in Canada, mainly through lending, but also through capabilities like analyzing cash flow and whatnot, and providing insights back to the company on how they're performing from a cash flow perspective. When we were Ario prior to the merger with Thinking Capital, we developed a fully automated digital lending platform, and then which is now the Thinking Capital platform. That platform is a 24/7, 365 Ruby on Rails platform, mainly deployed within Heroku, but it does utilize a number of services on AWS, and that's particularly relevant because the services that we use within AWS are form part of how we solve the problem that we'll be presenting today. And essentially, the libraries that we have developed at this point are tied to AWS, but could be extended out quite generally to really any cloud provider. And the other particularly relevant point about our platform is that it's a microservices architecture for the most part. I mean, some of the components are becoming monolithic, but for the most part, we do have a number of services that do come together to form the platform. So the specific risk we were concerned with and why we developed these two libraries was the risk of a data breach. And what we wanted to try and do, insofar as we thought possible, is we wanted to mitigate the risk to the company of our data being leaked out on the internet in an unauthorized disclosure. As a financial services company, you can appreciate that we do collect information that is particularly sensitive of both businesses and individuals. And of course, in Canada, we have PIPEDA. And under PIPEDA, it is under our responsibility as a company to ensure that we are protecting that information to an appropriate degree. So with all that as kind of a backdrop, the threat model that we looked at was, this is essentially a generalized view of our platform where we have a number of backend services kind of shown in the middle. Those services have databases. They have access to file stores. In this case, S3 is the file store that we're using. Of course, there's front-end services that speak to those back-end services, and then we do have an identity provider. The particular threats that we were concerned with were, of course, unauthorized actors gaining access to our information, and that information could reside in S3 or it could reside in our Postgres databases. The various threat scenarios that we considered were would there be misconfiguration, obviously remote attackers gaining unauthorized access. An employee either by accident or on purpose leaking the information as well. So what we tried to do when we developed these libraries is we wanted to try and mitigate these threats as much as we could. As you can appreciate, like I said, we store sensitive information both in databases and on flat files in S3. So some of the security requirements that we also considered were, we had, what I've shown is essentially a generalized picture of a very particular part of our infrastructure. If you look a little bit more broadly within our infrastructure, we do have a number of other security controls built into it. Centralized logging, automated monitoring, and alerting. And what we wanted to do when we built out these libraries is we wanted to leverage those capabilities as much as we could. And what we wanted to do, the core concept that we essentially adopted, which has been used before, it's not specific just to us as a company, is we wanted to force attackers to have to come to the platform and be on the platform to actually access our data. So what we wanted to do is essentially force attackers to act like a bull in a china shop, and then through our monitoring and centralized logging, essentially listen for the plate smashing everywhere. If we can use that as an analogy. So what we mean by that is we wanted to use what's called client-side encryption of information, so encrypting information prior to storage, and then using hardware-backed encryption keys that is tied to our infrastructure. So at a core concept, that's essentially what the libraries that we've developed allow us to do. And then what we can do through identity and access management is we can allow only specific applications to encrypt information and decrypt information. And what that allows us to do is essentially have part of our infrastructure, protect information, and have another part of the infrastructure access that as required. And that's particularly relevant, at least in our situation, and I'm sure it does generalize to most scenarios as well, where we have an online portion of our platform that's collecting this information, it's processing this information, it's returning results back to our customers. And then we've got essentially an offline part of our platform as well, where there's data analytics occurring. And that online portion is going to collect and store data and encrypt it, but there are there business processes, other parts within our pipeline that need to access that information. So IAM gives us that capability. And we wanted to, as I mentioned at the outset, we wanted to have something that was really easy for developers to use. We wanted to be able to allow developers to innovate and to solve problems without having to consider too much what's happening under the hood from a security perspective. So that was extremely important to us, and I'll talk a little bit about how we have achieved that. At least we hope we've achieved that. And then, of course, we wanted a standard solution for both flat files and database contents as well. So some of the solutions that we considered, so if you look at if you remember back to the threat model, we had our databases and we had our S3 buckets. So our databases, mainly they're all Postgres databases stored on running on EC2 instances within the Heroku infrastructure. So of course, there are solutions that exist for server-side encryption, whether it be for file system encryption or server-side encryption in the context of S3, where you can configure your buckets essentially to encrypt information stored in it. The issue we had there is that, of course, if they're misconfigured, the server-side encryption doesn't protect you, because the files that are within those file stores, of course, would be plain text files. So if that data is leaked, essentially we have a full-fledged breach on our hands. So it didn't allow us to essentially solve the problem that we wanted to solve. Disk encryption, very similar. Once that file system is loaded and running, of course, there's plain text information on it that could be leaked. There are a number of database-specific solutions that we consider as well. SQL Cipher and Postgres also has specific solutions for encryption. They were specific to DBMSs, of course, so it didn't allow us to solve the problem generally across S3. And and in our databases. And in a lot of cases, it didn't solve all of the use cases that we considered. But in saying that, what we did was we wanted to develop or combine, I should say, a client-side encryption solution with the server-side encryption solution. The server-side encryption solution, of course, solves against particular threats, and we wanted to augment that to protect us against the threats that I presented in one of the earlier slides. So the first version of the architecture was a fairly basic implementation. Essentially, what we did was we had applications registered within our IAM to receive keys to be able to register what are called customer master keys with our cloud-based HSM. Once registered, they're able to request encryption keys, at which point they get back a encrypted encryption key as well as a plaintext encryption key. Of course, the plaintext encryption key is used for encryption, and then whether it be a flat file or a particular data element that's stored in a database, that gets encrypted and then stored on a remote server. It's essentially a key under key solution where the customer master key is tied to a specific application. The data, the ciphertext that's stored is stored along with that encrypted key. And of course, once we're done the encryption operation, the plaintext key is wiped from memory through a secure wipe. The decrypt is no more complicated. Essentially, that encrypted payload is retrieved. The encrypted key is passed back to our HSM, which decrypts it, passes back our plaintext key to perform the decryption. And again, the key is wiped. So this was our first implementation of it. We have two libraries that we'll talk about at the end. We have said the libraries are PorkyLib and DaffyLib. PorkyLib is largely the solution that you see in front of you here. And then what Wei is going to get into in version 2 is largely DaffyLib, which is built on top of PorkyLib. So just to provide some more context in terms of, what is our solution currently built on? As I mentioned, we use IAM essentially to implement least privilege. So only specific applications can encrypt with specific customer master keys. Only specific applications can decrypt information stored with those keys as well. And we use IAM to essentially through policy to control all of that. We use S3, like I said, for flat file storage, configured, of course, with server-side encryption. KMS, Amazon KMS is our cloud HSM, and like I mentioned, we've essentially implemented a key into key solution. Under the hood in PorkyLib, we use libsodium for our symmetric and encrypt and decrypt operations. And then, if you remember at the outset, one of the requirements we had is we wanted to make it as easy as possible for developers to use. And in Ruby, there's a particular library called Adder Encrypted that was quite useful and instrumental in essentially the solution we've developed. And what Adder Encrypted does is it allows a developer to interact with a class, whether it be a database model or something else. And it can interact with the class in a very simplistic way. So if you have an attribute of a model, let's say it's sensitive, let's say, something like someone's date of birth, from a developer perspective, they can interact with that model with a simple accessor, getter and setter of .dob or .date of birth. But under the hood, Adder Encrypted allows us to plug in our PorkyLib to encrypt that information on write and to decrypt it on read. And this is really what allowed that seamless experience for our developers when they're interacting with database models. And of course, that's all built on top of libsodium as well. So at this point, I'll pass it off to Wei.
Yeah.
See if I can successfully do this.
I'll try sharing my screen.
I'll check if there are any questions before we.
Yeah, sure.
Oh, there we go. Okay, someone asked. That's how you pronounce Pipeta. Yeah, I don't know if that's official, but that's how I've heard it pronounced.
It's actually interesting because my son, who's in university, he actually had that come up in an assignment, and so it was a great introduction, which sort of shocked me that they were actually covering that. But I sort of wondered if I was, killing the pronunciation. So thank you.
No problem.
Yeah, so I've just shared my screen. If you can.
I can't see it yet. Oh, okay. There we go. Yeah.
Cool. Yeah, so I'll pick it up. So after implementing our first iteration of the solution that Brent just showed you, we ran into some performance problems. And the root problem of the performance issues was that the round trips to the KMS take a non-trivial amount of time. So for us, it was about 0.2 seconds per key, and this scales poorly. As if you look back at this slide here, we're basically making this trip every single time. So we want to cut down on how many trips we make. And so the running example I'll use is an API call we have called getMerchants, which retrieves data for many merchants at once. And our application in production sits in Heroku, which times out at 30 seconds. And so we were, in fact, getting timeouts. And so there was inefficiency caused by essentially two things that we ended up addressing. So the first is a lack of caching. So we go through that entire process, going to the KMS and coming back, even if we're requesting the same data again and again in rapid succession. And then the second point is that our key distribution was as granular as it could be. Essentially, every encrypted cell in each table got its own key, and that was kind of a function of the Ario encrypted library that we were using. So this is how we handled the partitioning, essentially. This is kind of a watered-down example. But on the left, you see here, so we have a merchant, and then we have another merchant. Each of them has a few encrypted fields, and each of them has two attributes. And again, so each single field here is a different color, which means that each one of these is being encrypted with a different key. So on the left, we have essentially 10 keys being used to encrypt this stuff. Whereas on the right, what we implemented is this concept of partitions. So partitioning the records in our database so that all the things in one partition would be encrypted with the same key. So for instance, here, the merchant class became a partition provider for both itself and for the merchant attributes that belong to it. And so now what we have is the unique identifier of the merchant together with an epoch, which by default we have set to 1 year. So those things together index into a single key for the entire partition. So now there's only 2 keys here, whereas before we had 10. So even in this simple example, we've cut down the number of keys that we need by a factor of 5. And this is just to kind of show you how, so basically we're using Ruby here, which is an object-oriented language. So obviously we have the notion of objects and objects belonging to other objects. And so that's essentially what we're leveraging here for the solution. And this is just to illustrate that it's not always the simplest case. So on the left is essentially what the example from the previous slide falls into. It's simply a class that has a bunch of children, and that class provides the partition to this entire structure. So everything here shares 1 key. But here are just a few other patterns that we ran into, and these are things that as a developer implementing the library, you do have to take care of. So for example, it could be a polymorphic owner. So your class could belong to either dad class or mom class, in which case you would have to get the partition from one or the other. There's also the case of optional owners. So your class could potentially belong to a parent class, but if it doesn't, then it would just get the partition from itself. And then finally, there's kind of this multi-level structure. So you could have a class here in the middle that is a partition provider for its child class, but it's actually getting the index of the key from its parent class. So this entire structure here would be 1 partition. And so in terms of caching, what that looks like, so this is similar to the previous slide that Brent showed you. The only difference now is that once we read and set the partition in epoch, so that indexes a key, we will request the key and see if it's been cached locally. If it has been, then we don't need to make the trip to the KMS externally, and we just return the plain text key. If it's not cached, then of course we go to the KMS, we'll get the key and return it, and also cache it for a configurable amount of time, which the default is 5 minutes, I believe.
Can I just interrupt for a second? Would you be able to make the slide a little bit larger?
Not sure how I would do that. It's kind of already full screen, right?
Can you zoom in somehow? Let me see if I can pull up.
Yeah, I'm trying to zoom in, but since it's already full screen, it isn't.
Okay.
Yeah. So essentially, this here is the locally cached encryption key. So I'm hovering my mouse over right now. and it's a fork. Is it cached? Yes or no? If yes, just come back. If no, then we go to the external KMS. And so on this slide, I have essentially the results of the performance improvement on our get merchants API call. So these are average times taken from 10 trials each. The yellow here shows essentially without partitioning or caching. So this is solution 1. So you can see that when we were requesting data for 25 merchants, we were hitting the timeout threshold. And so now in the green, you'll see the benefits that comes from just the partitioning. So the key hasn't been cached yet, but we're just using the partitioning to cut down the number of keys. And so you see there's already a significant improvement. And then in the orange, you'll see the benefits of both the caching and the partitioning. So once the keys are cached, and we're not making the trips again. So Brent theorizes that these orange values should actually be much closer to 0. So there's certainly something going on there that we still need to investigate. My theory is that there's possibly something going on that's not related to encryption that's causing the API calls to take some time. But in any case, we're now able to get up to 50 merchants without getting close to reaching the timeout, whereas before we couldn't even do half of that. Okay, so some trade-offs and next steps. So of course, partitioning the data this way causes a security performance trade-off because now a single key is responsible for more data. So a single leaked key can cause more damage. So whereas before a single key was encrypting, for example, just the first name of a merchant, now that one key is responsible for the merchant and essentially everything belonging to it. So of course, there's an engineering trade-off there, and as a developer, you have to think about what level of trade-off you're comfortable with. Because you could do the other degenerate thing, which is make your entire application one partition. So you get maximum performance, but then if you lose a single key, then you've lost everything.
I'll interrupt with, we just got hit with a question. So the question from Sid was, what was the trade-off for the performance improvement?
Right. So that's essentially what I'm covering right now. So yeah, there is a security trade-off here because if you lose a single key now, that key is responsible for more data. So the attacker can now essentially get access to more stuff based on just that one key. So yeah, that is definitely a consideration. And
so
there is also,
I can jump in there. Yeah. I can jump in for a sec there, Wei. So how did we come to it? Yeah, so like Wei said, I mean, you could go to one extreme, which would be essentially the whole application would be a partition provider. So you could imagine everybody uses the same key. So clearly that's, like Wei said, an efficient solution from a performance perspective, but doesn't satisfy in any way, really in any way, our ability to protect our data in the event of a breach. So the approach we took was what logical partitions existed within our platform, and really what it boiled down to is the most granular logical partition that naturally exists within our platform is at the customer level, which the merchant is what has been referring to, and that's that's essentially where we started. So we could go more granular than that, of course, but in terms of usability of our solution and security, it presented the best trade-off for us in terms of security and usability. And of course, we went through what we're not showing here is when we initially developed version 2, there was quite a bit of analysis that went into essentially what are reasonable partition sizes, so we could make that a determination essentially at what level we would partition.
Mm-hmm. Yeah, and then another trade-off is just the amount of dev work that it takes to implement the libraries. Right? Because as you've seen, there's a relationship between the classes that we're now leveraging to improve our performance. So you're kind of locked into so if class A belongs to class B and class B is providing the partition, if you now change that relation, you have to then go into the code or go into your database and then kind of redistribute the keys based on whatever your new partitions are. Right? And so one of the issues we ran into was actually with orphan records. So that's like when you have A which belongs to B, but then B doesn't actually exist in your database. So then it would try to generate the key from the partition from the provider which doesn't exist. So this was causing some migration failures. And of course, when you work on these kinds of platform things that touches the entire application, everyone else you work with gets mad at you. Yeah, that was fun. And of course, the last point of a trade-off, which is not specific to our solution, but just kind of general for any kind of encryption of data inside a table. So this disables indexing, searching, and other DBMS functions. So our partial solution to that is to add hashed values of certain encrypted fields that we need to search by, for instance. And so then the next steps are to continue monitoring the performance and seeing where we can make tweaks and optimizations. And of course, to just generalize the solution, because right now it's tied very specifically to this Ruby solution, either encrypted as well as to AWS. But there's no reason that it has to be. Right?
I'm wondering if the original, the time issue talking to their KMS, whether you would actually see that in other cloud providers like Google or Azure.
Yeah, it's a fair question. We I guess prior to developing this solution, we had already started to use AWS's services, and what we did, one of the reasons we did that is Heroku itself is actually is built on top of AWS, and it does allow VPC peering. So that added another security control that we could leverage. So for the most part, that's why we stuck with AWS. We actually didn't investigate if we moved to GCP or to Azure or anything like that, if it would improve the performance. But that would be a fair. But like Wei is saying, generalizing. Our solution would not be altogether that difficult for those providers because they essentially provide exactly the same services, right? So,
yeah, and I'm just going to double check. There was another question about caching, and I just want to make sure you already covered it about the caching of plain text keys and how that affected security. I'm wondering if you already covered that.
Yeah, so there's a couple controls we have in place there. So there's obviously the caching. There we go. Yeah, it did caching so it does, and that's where the trade-off between security and performance was relevant as well. So yes, if you have multiple columns or multiple attributes encrypted with a single key, the number of keys becomes less, and that bull in the china shop now needs to make less noise. So that's certainly a trade-off. Of course, if the way we've partitioned it requires for any given attacker to come to our platform to be able to access, quite a large number of keys at this point in time, to the degree that we should be able, the hypothesis is that we can detect that and shut it off at that time. And then, like I said, there are additional controls that factor in to reduce that risk as well. But certainly that's the trade-off, right, with version 2. We're going from the ultimate secure solution in version 1 to something that trades security off a little bit with performance.
Okay.
And recall also, this is completely configurable by whoever uses the library. There's nothing forcing you to use a particular class as a partition provider. You can choose to make it as granular as you want and apply it, say, only to models where you feel comfortable with the loss in security.
Thank you.
And then some final concluding notes. So essentially, we've developed a configurable solution that enables dev teams to implement client-side encryption. And as Brent mentioned, we have now 2 open-sourced Ruby on Rails libraries that you are free to have a look at and use. So they are Porculib and Daffylib, because we like to name everything after Looney Tunes characters. And so essentially, yeah, so these projects are continuing to be under active maintenance, and we're still monitoring for performance issues. So we get alerts if there are timeouts, and we also get alerts if there's any queries that take longer than 2 seconds. And as I've already mentioned as well, that Porculib and by extension Daffylib, which is built on top of it, is tied to AWS at the moment, but there is no reason for it to be, and it's kind of the logical next step in making this work more usable for the community at large. So that's it for the presentation. If there are any other questions.
I have a question. What's your AWS bill like?
Actually, it's not bad.
Okay.
A Heroku bill, on the other hand, is a different story. I don't know if Heroku's got Heroku's got some really nice properties about it, but certainly its price is not one of them.
Right. Okay.
Yeah.
It's food for thought, because I mean, my Twitter feed is just full of AWS bill memes. So it usually involves, some manga character and the Terminator. And the Terminator is the AWS bill. So I have to always ask, because that seems to be the bane of a lot of cloud existence. So
not ours yet, but maybe one day.
Right. So any particular reason for the choice of using, and there's no wrong answer here, but I'm just curious as to the choice of Ruby for your environment. Is it because you're mostly a Ruby shop, or was there any particular, or is there, another specific reason why you work with Ruby? Are you Ruby-nistas, I think is the term.
So at this point, we're essentially 3 years in. So I don't know, we're at that level of Ruby experience. The vast majority of us, when Ario was started, some of the founding members of the organization were Ruby, well experienced in Ruby, and that's essentially who started the infrastructure at that time. And kind of as people joined the organization, including myself, we all learned it, and I guess to a certain degree enjoyed developing in it. So we stayed long enough, and that's essentially how we started on the Ruby on Rails track. The Ruby on Rails is essentially our back end. It's our services. Our front ends are Angular, and then our data pipeline is a completely different technology as well. But the core platform is Ruby for essentially because of the two first developers that were through the door.
Awesome.
Yeah.
Well, thank you very much. I'll just check the chat. Other than references to my meme, I think that's it. So thank you very, very much. It was extremely interesting, and it's always good to see some good cryptography projects moving things along.
Cool. Thanks for having us. I appreciate it.
Thank you very much.
Awesome. Well, at this point, what I'm going to do is see if our next presenter is online. And unfortunately, I think she's got her mic muted.
Hello, can you hear me?
Yes, I can hear you. So I think I'll start with the introduction. Colleen is joining us this evening, and she's a software engineer at R2C, which is a startup building static analysis tools that focuses on precision and being custom fit to the consumer. So there you worked on language parsing along with AST matching, and you're also writing rules to find security vulnerabilities in open source codes. So you've recently got a BS in computer science and a MS in statistics from Stanford. So that sounds, but probably what's I find very interesting about your bio is that you are into Brazilian Jiu-Jitsu. So you're going to have to tell me about that, because I'm a bit of a karate nerd, so I have to learn something about Brazilian Jiu-Jitsu. But you're going to talk to us about Semgrep, which is something embarrassingly, I know nothing about. So I'm really looking forward to this talk.
Definitely. Thanks for the introduction, Garth. Yeah, so essentially I'll be talking about detecting complex code patterns using something called semantic grep. Let me just share my screen very quickly. Awesome. Can you see my screen?
Yes, I can.
Okay, perfect. All right, so hi guys. Okay, I'm Colleen, and today we'll be talking about detecting complex code patterns using something called semantic grep. And sometimes, essentially, you'll want to identify some specific patterns in your code for either security purposes or for perhaps coding best practices. And you might think about using grep in these cases because it's easy to use and quite fast. But oftentimes, grep gives you pretty noisy results because it doesn't fully understand code. So I'll be talking a little bit about what we've been working on, a tool called Semgrep, which actually makes writing custom rules pretty easy and makes your search a little bit less noisy. So Semgrep is actually a static analysis tool, and static analysis essentially involves programs analyzing your source code. Awesome. So a short TLDR of this talk is essentially secure code is difficult, and static analysis tools are oftentimes too noisy or too slow. And grep essentially oftentimes isn't expressive enough. So you might need something that's sometimes fast, code aware, a little bit flexible, and quite powerful, and also open source. So let me just introduce Semgrep, which is a fast and syntax-aware semantic code pattern search for a lot of languages. And you can think of it as a code-aware grep. Cool. So Semgrep can be used to find security bugs if you're a pen tester, or if you want to find some vulnerabilities in GitHub repositories. It can also be used to enforce specific patterns and also coding best practices. And you can also easily migrate from some deprecated APIs. So I'm Colleen, and I'm currently a security software engineer at R2C. And I recently graduated Stanford with my bachelor's in CS and my master's in statistics. And R2C is a SF-based static analysis startup, and our mission is to essentially improve software security and reliability. Awesome. So here's a brief outline of what I'm just going to be talking about today. So we'll give a brief background about how Semgrep started, and then we'll talk about grep and abstract syntax trees. After that, we'll give a few Semgrep examples, and then I'll demonstrate how to use Semgrep for mass scanning. We'll talk a little bit about integration into CI/CD, and then look at the Semgrep rules registry, what we already have available for you. So Semgrep is open source and has a long history of being open source. So you can check it out on our GitHub page. So Semgrep was actually built in 2009, and it was written at Facebook and used to enforce a lot of rules. The original author, his name is Johan, he actually joined R2C last year and was the first static analysis hire at Facebook. He got his PhD at INRIA and is a contributor to Coccinelle, which is used for Linux kernel refactoring. And Coccinelle is used to match and transform C code. So we actually have support for a handful of languages. So we have pretty thorough support for Java, JavaScript, Python, and Go. And we have beta support for C, JSON, OCaml, and Ruby. And also we just released TypeScript and PHP support. PHP is in alpha, so keep an eye out for those. Cool, now that we've done a really brief background review, let's talk a little bit about grep and abstract syntax trees. So let's imagine a situation where we have this large database and we want to find a specific snippet of code in our code base. So we might think about turning to regexes, regular expressions, which makes a lot of sense because they're super great for rapid search and run really fast. But if you've used regexes for searching for code, you might get things like comments or documentation. And sometimes it turns out to be super noisy. So it turns out to be a bigger headache than it's worth occasionally. So why is regexes so hard? Why is it so bad at, why are they so bad at actually getting your code or the code that you want to find? Well, the issue with regexes is that they don't truly understand code because code is not a string, it's a tree, right? So if we remember back to our compilers or programming languages classes, code actually gets parsed into what's called the abstract syntax tree, or AST for short. So in short, Semgrep lets you actually easily search at the AST level, not the string level. And this means that Semgrep actually knows when something's a function call or a function definition, a string literal, or something else. So there's a lot of AST matching tools, and one of them you might have heard of is ESLint. So essentially, you might think about writing your own AST matching tool for your code base, right? But this is sort of difficult because each language actually has a different grammar, and each grammar parses into a unique AST. So in order to actually do AST matching on your code base, you would have to write AST matching code for each language in order for that to work on your code base, right? And this is a pretty high barrier to entry because AST matching code and parsing a language into its AST is quite difficult. So essentially, writing tree matchers has this barrier to entry. And we see on the right this ESLint code that actually finds calls to eval. And we see that it takes 300 plus lines of code in order to find these eval calls. So there are commercial SAS tools, static analysis tools that are available, but these are pretty complicated. They're slow and oftentimes cost a lot of money. So Instagram actually published a pretty insightful article last year with this graphic that shows the static analysis spectrum. So on the left, we have our usual regular expressions, which are pretty easy to write, but limited in their use case. And on our right, we have our whole program analysis, such as Py and MyPy. And whole program analysis essentially analyzes the entire program, as you can tell from the name, and tracks data flow and traces user input from its source to its endpoint. So essentially, these whole program analysis tools are super powerful, but they're also pretty complex. So they aren't easy to customize, and it's often pretty time-consuming to set them up and write patterns for them. So where does Semgrep sit? Semgrep sits somewhere in the middle. So it provides a pretty easy interface to match tree representations of code, and it also operates on files. So it doesn't actually run through the entire program, which makes it a little bit faster than usual. So the key insight to Semgrep is that it lets you reason about your analysis the way you reason about your code. You can click on this blog link in order to find out more about this. Cool. Now that we've talked a little bit about Semgrep and its background, let's try to talk a little bit about some Semgrep examples. So here's an overview of our demonstrations that we're going to be doing today. So we'll first be doing a Semgrep overview of just what Semgrep has and the features it contains. And then we'll talk about Semgrep in practice and what you can use and do with it. And then finally, we'll talk a little bit about some advanced features like autofix. So as a note, Semgrep can be run in the command line interface through pip, root, or Docker, but we're going to be using something called semgrep.dev in this talk. So semgrep.dev is a pretty nice online live editor wrapper that goes around Semgrep. So Semgrep patterns are basically just the source code you're targeting, unlike a lot of other ASC-based tools where you have to learn an entirely new language. So when we're trying to search JavaScript code, we're just going to be writing patterns that are mostly just JavaScript. But Semgrep has two pretty helpful abstractions, the ellipses operator and something called meta variables. So I'll give an example of each, but let's first take a look at the ellipses operator. So the ellipses actually abstracts away just sequences of things. So these things could be arguments, they could be parameters, could be entire statements. So you can think of it as the dot star in regexes. Awesome. So let's consider this case where there's a function you know you don't want to be used. It might be secure, super outdated, or not supported anymore. And a good example of such a function is node exec function. And node exec is bad because it could lead to command injection if there's any user-controlled input passed into this function. So let's take a quick look at this pattern. Awesome. So let's first look at this test code. We see that there's 4 exec calls with different arguments passed into exec. And we also see that there's a console.log to exec bar and a comment. So let's first do a simple thing. Let's just copy and paste this exec call into our pattern code and see what it does.
Can you just see if you can increase your screen size a little bit?
Yes, definitely.
the code itself is the important part. The stuff off to the right is probably not as important. Yeah, that's a bit. Thank you.
This is better. Okay, awesome. Thanks for letting me know. Right, so we see that this pattern exec foo matches exactly what we would expect it to. Just the exact match, right? But honestly, when we're trying to match and find exec calls, we don't really care what argument we're passing in. We're just trying to find the call to exec, right? So let's try using this ellipses operator, which just obscures away arguments that are passed in. Awesome, so what does this do? We see that it matches every call to exec, but it doesn't match the comment or the string literal, right? This is because Semgrep is sort of syntax aware and it knows exactly what's a comment and what's a string literal. Awesome, so now that we've matched all exec calls, let's move on to the next example. So I'll introduce a new concept here called meta variables. And meta variables are sort of like capture groups in regexes. So sometimes you don't know exactly what you're trying to match, but you want to grab a reference to this match later. And again, in this case, there's this package that we don't want to be using, the unsafe package. So unsafe actually opts out of type safety for Go programs, and this can lead to memory vulnerabilities. So let's try to find all function calls from the unsafe package. And unsafe actually has quite a number of functions, and we could use the example we did earlier to sort of find a pattern and write a pattern for each function in unsafe. But that's such a huge pain because essentially there's a lot of functions in unsafe. So instead, let's use meta variables in order to write this pattern. Awesome. So essentially we see in this test code that we're calling unsafe.pointer a few times over here, and then we're calling unsafe.sizeof and another unsafe.pointer call over here. So let's do our favorite thing, copy and pasting, and just put it over here. So we can do what we did before in the last example and just use ellipses to obscure away the arguments that we're passing in. And we can do this because we don't really care about what arguments are passed in currently. Awesome. But because we're only matching calls to unsafe.pointer, we're not matching this unsafe.sizeof call, right? So let's use meta variables in order to match unsafe.sizeof. So you can create a meta variable in Semgrep by using the $ and then naming the meta variable. So meta variables are always all caps. So I'm just going to name this meta variable func to represent a function. Awesome. And we see that it's matching unsafe.sizeof and unsafe.pointer. So I'll actually match any function from the unsafe package in this case. Cool. Now that we've talked a little bit about the ellipses operator and also meta variables, let's try to combine what we've learned. So we might want to detect some possible security vulnerability in our code. So in this example, there's a path traversal vulnerability in this function because we see that the file name, which is user supplied, is passed to the send file function, right? And this means we can try to serve, an attacker can try to serve any file in the server's file system. Cool, so let's try to write this pattern. So cool, the test code is essentially what we saw in the example in the slide, right? It's essentially, there's this user supplied file name, which is passed into send file. So let's do our favorite thing, copy and pasting, and try to sort of generalize this pattern. So one thing to note is that because Semgrep is syntax aware, it knows that you're trying to import send file from Flask. And it knows that send file is essentially a function of Flask. So instead of actually just saying send file, we would need to do flask.sendFile. So over here, when we're trying to return just send file in the pattern, we would need to do flask.sendFile instead. And we don't really care what the route name is. So we're just going to obscure that away with the ellipses operator. And we also don't really care what the file name argument is called, but we want to store this later to make sure that it's getting passed into the send file function, right? So I'm just going to obscure this away with a meta variable f name. We also don't really care what the function is called, so let's use another meta variable to represent this function. And also, we don't really care what the function does inside. We only really care about the return statement, right? It could be printing something, it could be doing nothing, doesn't really matter to us. So let's obscure away these statements with the ellipses operator. Cool. We also don't really care whether as attachment is true or false, or if there's any other arguments passed in. So let's obscure that away with the ellipses. And we want to make sure that the file name that's passed in by the user is being passed into the send file function. And meta variables that are named the same thing are actually going to be equivalent objects. So essentially, we can use this f name over here to supply into the send file function. And we'll make sure that these two objects represented by this meta variable f name is the same. So let's see what this catches. Awesome. So we see that we're catching this example, and we'll be catching other more generic examples of this path traversal vulnerability.
Can I interrupt with a question? We have a question, and it's about the func meta variable.
Mm-hmm.
It's, well, that's not the first one. This is the first one. So func is a predefined word.
So func is not actually a predefined word. You can name it anything you want. The only thing that holds for meta variables is that essentially meta variables with the same name will be equivalent objects. But you can name it func, you can name it fun. It doesn't really matter.
Right. So in your previous example, you just chose, that was just a common word that you would use. You could say, literally anything to represent that block.
Right. Exactly.
Okay. Awesome. Thank you.
Yeah, thank you for the question. Awesome. So let's move on to talk about a little bit more of Semgrep functionality. So sometimes we might want to do something a bit more complicated than just finding a specific pattern. So we might want to find code where A and B occurs, or A and not B occurs, or A occurs or not B occurs. Or essentially, we might want to combine some pattern clauses. And Semgrep actually provides a way to do combinations like this by having multiple pattern clauses. So I'll show you how to do this in this example. Right, so in this example, we're trying to enforce another security default. So when we set a cookie, we want to make sure to set it with secure headers like HTTP only, which protects the cookie from being read with JavaScript, and secure, which actually limits cookies to HTTPS traffic only. So let's use the and not clause in order to catch cookies that are being set insecurely. Let's click on this link. And look a little bit at this test code. So we see that we're setting this cookie with username Drew Dennison without these secure headers that we talked about before. And this is not good, so we would want to catch this case. And this case is actually also not good because we're explicitly setting secure to false. So we also want to catch this case. But this one over here is okay, right? Because we're setting secure equals true and HTTP only equals true. So this is okay, and we don't want to catch this case. So let's do our favorite thing, copy and pasting, as usual. And let's just try to get all the calls to set cookie first. So let's obscure away the arguments with the ... And as we see, we're importing response as R from Flask. So essentially in Semgrep, as we talked about in the last example, we would need to specify that it's flask.response that we're looking for. So let's run this and see what it's catching. We're catching all three of these cases, right? Because we're catching every call to set cookie as we expected. But we don't want to catch this case, right? Because the cookie is using secure equals true and HTTP only equals true. So let's use and is not in order to not catch these okay cases. And we can use and is not to filter these cases so that we have less false positives. Cool, so let's do our usual copy and pasting. And instead of R, we want flask.response as usual. And we don't really care what's to the left of the secure equals true. We also don't really care what's to the right of the HTTP only equals true. So let's see and test what this does. Cool, so we're not catching this case, right? Because we're saying explicitly that we're trying to catch all cases of set cookie where the cookie does not have the secure equals true and HTTP only equals true headers. But we do catch these insecure set cookies. So we have a bunch of docs, and you can check out all the pattern clauses we have on GitHub. And we have a bunch of pattern clauses, and metavariable regex is a pretty recent one. So feel free to just click on this link and check out our docs. Awesome. Now that we've gone through a brief overview of Semgrep, let's talk about Semgrep in practice.
So just a quick question. So it looks like there is a community-supported library of already known bad that people can use directly.
Oh yeah, definitely.
Okay.
We'll talk a little bit about the community-supported registry after our examples. But
Okay.
yes, definitely.
Sure.
Thanks for the question. Right, so Semgrep in practice. Essentially, we can use Semgrep for enforcing these security defaults, but we can also enforce coding standards and coding best practices. So for example, we can block anti-patterns and flag some company-specific code patterns so that push code always follows company-specific guidelines. So in this case, let's try to catch this anti-pattern. And this is bad because essentially we're catching this case where the if statement will always return true, right? And the else statement will never run. So the else statement is essentially just dead code. And let's try to catch instances of this. So let's go to this link. Cool. So in this link, we have the exact test code that we saw on the slide. And we have this brief, simple example where we're catching cases where a metavariable is set equal to a metavariable. And because they're named the same thing, the objects represented by the metavariable are the same thing. Cool. So let's try to generalize this and catch this entire statement, right? So let's do our usual copy and pasting. And essentially, we don't care what the metavariable is named. So let's just do what we had before, $x equals $x. And essentially, we don't really care what's after the if statement. We only want to catch this dead code. And we don't really care what's after the else statement either. So if we do this, we're able to capture this entire thing. All right, so that's just a case of how we can enforce coding standards and best practices. Awesome. So in another instance of using Semgrep for our coding best practices, there are some cases in which we must enforce the order of API calls. So in a lot of apps, there's cases where we want one API call to be made before another, right? And maybe it's because the first API call sets up some global state. Maybe it verifies the data in some object, or it does something else. So in this particular example, we'll be looking at a hypothetical financial trading application. And in this hypothetical trading application, a transaction has to be verified before it's made. So let's just look a little bit at this code. Right, and so essentially this is the test code. And we can see over here that this is okay, right? Because we're verifying the transaction before we're making it. And this is bad, right? Because we're just making this transaction without verification. And this is also bad because we're just making the transaction and then verifying it, which doesn't really make sense. But over here, we're not capturing a bad case where we're verifying transaction other and then making transaction T. So let's try to edit this pattern to make it catch this bad case too. So as you can see, we're sort of using the and is not that we've used in the cookie example. So let's just take a brief look at these patterns. So in this pattern, we're just looking at any function that calls make transaction. And we don't really care what's passed into the function as arguments. We don't really care what's before the make transaction call or after the make transaction call, right? And we're filtering out cases where the function is calling verify transaction before it's calling make transaction, right? But we're not specifying that the transaction that's being made is the transaction that has been verified. So we can specify this with a meta variable. And so let's name the meta variable t and to specify transaction. Awesome. So we want to verify $t and also make $t, right? Because meta variables named the same will represent the same thing. Let's try to run this and see what happens. Give me a sec. I think there's some caching going on. So it seems like we're not capturing this case over here. But essentially, we are capturing the other cases. This is interesting. And this bad case. I think there's something been done to the parsing, so we'll take a look at that later. Cool. So now that we've talked about Semgrep in practice, we'll talk about the advanced features after. So Semgrep can be pretty useful for getting visibility into your code, not just for finding bugs. So let's say we want to get all the routes in our code. So we can say, show us all our routes, show us all the post routes, show us all the routes that don't do an authorization check. And Semgrep can also be hooked into your CI, so you can know when someone adds new routes. And we can use this pattern over here to capture specifically Go routes. And as you can see here, we're matching all of these Go Gorilla routes. And essentially, what we're doing is we're capturing all these cases of router.handlefunc, and we don't really care what the route is called or the handler function. We also are capturing any case of method and HTTP verb. So over here, we're printing out essentially the route name and also the handler function along with the HTTP verb. So if we want to specify to only get routes, we can use that and just specify get instead of HTTP verb. Same with post and other routes that you want to sort of zoom in on. Awesome. So there's also this visualization that we've built on top of route detection that we think is pretty cool. So we've used this in security audits of code bases, and we use Semgrep to extract info, and then we visualize the routes with D3. So you can get a pretty good visualization of what routes you have. Right, and so right now we've been mainly focusing on pinpointing where the issues are in code, but it'd be really nice if our tools don't just pinpoint our problems, but also help us fix them. So Semgrep also supports the ability to not just find patterns, but also to enter a fix for the pattern that you can then pretty easily apply. So let's take a look at this example, which is an insecure SSL configuration example. So when we're writing application code, we want to make sure that the version of TLS we're using is essentially TLS 1.2 or higher, right? Because TLS 1.1 has been proven insecure because there's cryptography attacks filed against it, and SSL, the predecessor to TLS, is also vulnerable to crypto attacks. So let's write this rule in order to detect these insecure SSL configurations. Awesome. So over here, we see that this is an insecure SSL configuration because our minimum version is SSL 3.0. And we want to make sure that we capture these cases. And our pattern in this case is essentially, we don't really care what's on the left of it. We don't really care what's on the right. As long as this configuration object contains minimum version SSL 3.0, we're going to catch it. And our fixed regex is essentially we're matching version SSL 3.0 with version and replacing it with version TLS 1.3. And over here on the right, we see that we have our matches and there's this auto fix suggestion. So we can apply fix and we see that this has been converted directly to TLS 1.3. So you can specify the matching regex and also the replacement regex. So you can specify whatever regex you want, etc. So Semgrep is also designed to be pretty flexible. So it's actually scriptable with Python. And you can use this special pattern where Python calls to write a Python Boolean expression. And this will only match if the expression is true. So this is pretty useful in doing some numeric evaluations. And in this example, we're enforcing another security default. So when using RSA with public and private keys of pretty short length, this is bad because essentially we can brute force short length keys. So let's say that we want to make sure that our key lengths are above or equal to 2048 bits. Awesome. So essentially over here in this pattern, we see that we're calling rsa.generateKey, which generates a RSA key pair. And we're calling it with 1024, the number of bits. Over here, this is okay though, right? Because we're calling it with 2048 bits. So in this pattern that we've written, essentially we're calling rsa.generateKey, and we don't really care what's specified before bits, but we're capturing the number of bits that rsa.generateKey has with this meta variable. And we're using patternware Python to get the integer value of these bits and then compare it to 2048. And it doesn't really matter what number this is, could be 512, for example, and we'd still catch it, right? Because of this patternware Python script. Cool, so now that we've gone through all of our examples, let's talk a little bit about using Semgrep for mass scanning. So from the examples we did before, we can see how we might use this tool to sort of scan for vulnerabilities. And let me show you how we use Semgrep internally to find vulnerabilities. So we have a few CVEs, and one of the CVEs we use this pattern in order to find. So let's take a closer look at this pattern. The pattern actually looks for Flask routes that uses this route parameter to open a file, right? And essentially, we see that this file name is user supplied, and then we're filtering this into this open statement. And this pattern actually uses something called the deep expression operator, which essentially tells Semgrep that file name can appear in any expression in this first argument, and it'll still be found. So for instance, it might be involved in a string concatenation or os.path.join, and the tool will still find this file name. Right, so essentially we see that this is insecure because we are calling open to os.path.join with a user supplied file name. And we can see that this is the pattern that we saw in the last slide, and this pattern is capturing this path traversal. So if you click, we have this analysis platform called the Massive Analysis Platform, MAP, where essentially we can select an analyzer, and in this case, we're selecting Semgrep, and we can also select an input set. So we have input sets of the top 1,000 Flask applications, the top 1,000 Node.js applications, etc. And we can use this to sort of scan a bunch of GitHub repositories. And we can review the results with some nice graphs of them. And we managed to catch this path traversal vulnerability using this process. Awesome. we've talked a little bit about using Semgrep for mass scanning, let's talk about integration into CI/CD. So it's pretty useful to enforce some secure defaults and secure frameworks at CI time. So Semgrep is quite easy to integrate into your CI, and it also has JSON output, which is pretty easy to integrate with other systems. So if we go to semgrep.dev, and for instance, if we want to essentially add this rule to our CI, we can do so by clicking the share button. And we see this use in CI tab over here, and we can use it in GitHub, GitLab, CircleCI, Appfair, and Travis. And it's pretty easy. You can click this clipboard button and then just paste it in the YAML file. And this is Semgrep running as a GitHub action in one of our Flask applications. So it actually detected a path traversal vulnerability. As you can see, we see that there's this path traversal -open rule that's been caught. And essentially, we managed to detect that by running Semgrep in CI. Awesome. So now that we've talked a little bit about CI/CD, let's talk about the Semgrep rules registry. So if you think that maybe this tool sounds nice, but you're pretty busy and don't have time to write a bunch of custom rules, you can check out the community registry. There's a bunch of pre-written rules that you can just get out of the box. So there's actually close to 1,000 rules under development by the R2C community. And there's rules contributed by Damien, who's the author of Go Perfbook. Node.js Scan v4 is also powered by Semgrep, and we have the GoSec and FindSec bug checks ported. So you don't need to compile anything. You can just download Semgrep and run those. We also have rule ideas contributed by the Django co-creator and rules written by some independent security researchers via HackerOne. So it's quite easy to run the rules from the registry. So you can just brew install Semgrep and then point Semgrep at a specific URL. And here's a brief overview of what the rules registry looks like. So if we go to semgrep.dev and then we click explore, we can also see what's the most popular rule sets and also some good rule sets for specific languages and frameworks, and also some enforcing secure guardrails rule sets. So if you ever want to search for a specific rule in our rule sets, you can go to this rules tab over here, and essentially you can sort of specify what languages the rule is in, what severity it has, what categories it has, and essentially, interesting. Yeah, and essentially you can specify, for instance, if you're looking for MD5 rules, you can pull up MD5 rules. And we can see essentially the name of the rule and also basically what examples it's matching. So you can show the Semgrep pattern and copy and paste this if you want, or just look more thoroughly at it. Right, so that's the registry that we currently have. Awesome. So now what are we working on? So we're working on more rules, of course, and some prevention cheat sheets for cross-site scripting. We're also working on something called Semgrep Community, where you can centrally manage Semgrep on your repositories. So if you look at this screenshot on the right, this is Semgrep Community, and you can essentially run specific rule sets on specific repositories. And you can specify whether it's notifying or blocking CI. We're also working on our VS Code extension, which is in beta, and also on tainting and constant propagation. So constant propagation is essentially the process of substituting the value of known constants in expressions at compile time. And also tainting is essentially tracking user input sources, which are possible locations of vulnerable code, and tracing the input sources flow through the program. So for instance, if a variable that's controlled by a user is then reassigned to another variable, the reassigned variable is also tainted. So it just tracks these taints down the file. Awesome. So essentially, that's the talk, and it's pretty easy to get started with this tool. So you can install it pretty directly using brew or pip, or you can try it online with the live editor. And it's also available as a Docker container, so you can just install it the way you want. Also, please consider taking the survey for us at r2c.dev/survey. We would really, really appreciate knowing what you think. Awesome. Are there any other questions that we have missed?
No, I've been keeping an eye on them, but I have one. Is the beta for VS Code, is that open or a closed beta?
I think it's open beta, so you can test it out now. Yeah.
Is there any plans for any other integrations with any other IDEs?
So not currently. VS Code was actually sort of a hackathon side project that one of our engineers did. Yeah, so we don't currently have any plans for more IT extensions.
Right. I noticed the list of integrations with CI environments. Is there any plans to extend those?
Yeah, there's definitely plans to extend those, and we're working on getting more CI integrations in there. So keep an eye out soon, and we'll have more of those.
All right. And here's a side question. How does your Brazilian Jiu-Jitsu affect your direction in your security career?
Thank you for the question. Yeah, Jiu-Jitsu, I think, is one of those things that once you start doing, it's like super addicting. I'm sure it could be the same for karate. And I feel like I'm unable to do jiu-jitsu right now because of, COVID and the likes. Yay. But yeah, I'm feeling that loss pretty significantly. It's definitely always a good mental release and stress relief thing. So right. having that taken away by COVID is sad, but it could be worse.
I've just sort of anecdotally noticed a sort of a combination of security practitioners in any particular sphere of security and having some kind of a martial arts background.
Physical security and cybersecurity.
Yeah, I think it's a way of thinking, and I think somehow there's this connection. So comment about VS Code. So I think there's going to be a few interested parties for that. This has been awesome because, like I said before, I came into this presentation not knowing anything about Semgrep, and it's something I'm going to definitely have to check out, particularly integration with VS Code and GitHub and CI is, I think, pretty good. Plus, I want to check out what you've already got in the can in terms of the community lists because, it's one of those things where the same error keeps repeating. And so if you see it in one place, it'll happen. If you have a rule there to keep Bob from checking in code, that would be great too. But, I can only ask for so much.
That would be hilarious. And also, I think a great time.
Yeah, awesome. So again, thank you so much, and thank you to Brent and Wei Yun for presenting. This has been extremely educational from my part, and we'll look forward to your next presentation submissions.
Thank you so much for having me. Have a good night.
Thank you. Everybody else, we will be having another presentation in November. So have a look at, keep an eye on our Twitter feed and all our other anti-social medias. And we will announce a date and the presentations for that, as well as keep in mind our survey. And stay safe, wear a mask, stay 2 meters away from everyone, and we'll see you in November. Thanks again.